So what's the setup? Limit as h approaches 0 of?
Minus f of 3
Good.
over h.
Very good. Limit as h approaches 0 of f of 3 plus h minus f of 3 all over h. So both of those x's will be replaced with 3 plus h. Good. F of 3. So let's actually find f of 3 right now to save some space. So if you were to plug in 3 into the function, what is 2 times 3 squared minus 5 times 3? How convenient. 3. All over h. If you would, those first two terms, square out the 3 plus h, distribute the 2, then also distribute the negative 5. Keep in mind this is a polynomial, just like our previous two examples. So things should cancel out nicely. What happens to the 18, the negative 15, and the negative 3? 0. What else combine? Would make. So we have 7h plus 2h squared over h. Since I'm running out of room here, I'm going to skip the step where I factor out the h. That's what you should be doing next. So after you factored out that h and the h's would cancel, what would you be left with? So as h's go to 0, what does 7 plus 2h go towards? 7. Awesome. Okay. So instantaneous rate of change, for right now, think of it as the slope of the tangent line. It's going to get a new name in a second. That's part A. Part B now says, find the equation of the tangent line. Here's the deal. You're asked to find the equation of a line. We're going to ignore the word tangent for now. To find the equation of a line, you either need two things, or you're in two cases. You either have 2 points. Well, do we have 2 points? No, we only have 1 point, namely at x equals 3. So if you only have 1 point, then you need to have a slope. If only we had previously found the slope. 7. That was part A. So we have a slope is 7. We have the x coordinate of the point is 3. How do we find the y coordinate of the point? We did that already. Where? F of 3. So if you know the x coordinate, to find the y coordinate, you just plug it back into the function. Well, we already did that. That was our f of 3. So we have our point. X was 3. Coincidentally, y was 3. That was the f of 3. And we have our slope, that being 7. So if we have a point, and we got to slope, if only there was a form of a line that used a point and a slope. Point slope! What is point slope? So our y1 and our x1 are both 3, coincidentally, and our m is 7. So we'll have y minus 3 equals 7, x minus 3. And typically we solve for the y, so we'll distribute that 7 through and then bring that 3 over to the other side. So this will give us the line y equals 7, x minus 21, so minus 18. Not at all. And then you solve for b, totally fine. Yeah, so what she's mentioning is you can take this one, y is 3, m is 7, x is 3, and then you can solve for b, and you also get negative 18. So your choice does not matter. Alright, so let's see this in action now. Let's see what we just did. You don't have to repeat this, just watch what we're doing. Clear U, I can always type U in again. So if I type in the 2x squared, what was it, minus 5x? And if I type in our line here, 7x minus 18. So when I graph this, we should see our parabola. And then at x equals 3, it's hard to tell because, you know what, let me make the window a little bit wider so you can see the parabola branch out correctly. So there's our parabola. And there's our tangent line at x equals 3. So that's what we just found. The equation of the line that hits the parabola at the point 3, 3.